Hello dear student. Exercise 11.3. Question number 1. In each of the following cases, determine the direction cosine of the normal to the plane and distance from the origin. This is the 4 different. Z equal to 2. B question is this. This is the C and this is the D. Now, first of all, we know the equation of the plane in AX, BY, CZ equal to D. So AX plus BY plus CZ equal to D. This is the equation of the plane. Now, Z equal to 2 means coefficient of x0, y0 and z equal to 2. This we can write. Now in this A, B, C, this is A, this is B and this is C. This is nothing but the direction ratio of the given plane. Okay. Now in this case, direction ratio of normal are 0, 0 and 1. 0, 0 and 1. So 0 square plus 0 square plus 1 square we have to find out, and this is coming 1. And after that, when we will divide in the plane, just we have to divide this value in the given plane. So this is coming in the form of Lx plus My plus Nz equal to D, where L, M and N value are nothing but the direction cosine of normal to the plane, as well as D is the distance of perpendicular from the origin. This is very important. This you have to remember. So Lx plus My plus Nz equal to D. L, M and R direction cosine of normal to the plane, and D is the distance from the origin. Therefore, in this case, 0, 0 and 1, 0, 0 and 1 are nothing but the direction cosine, and the distance from the origin is 2. Distance of the plane from the origin is 2. Question B, x plus y plus z. First of all, from the direction ratio, just we have to take the square root of a square plus b square plus c square. This is coming √3 and divide in the given plane. So after dividing, we are getting 1 by √3x, 1 by √3y and 1 by √3z equal to 1 by √3. Now this is the form of Lx plus My plus Nz equal to D. L, M, N are direction cosine of normal to the plane, and D is the distance of normal from the origin. Now this is nothing but the direction cosine, and distance of normal from the origin is 1 by √3. C, 2x plus 3y minus z equal to 5. Always remember this distance, the equation of the plane is given. Just 2, 3 and minus 1 is the direction ratio. Just square root of this we have to take. This is coming root under 14 and divide this in this given plane. So when we are dividing, we are getting 2 by √14x, 3 by √14y, 1 by root under 14z, 5 by root under 14, and Lx plus My plus Nz in this format. L, M, N are direction cosine. So this value are nothing but the direction cosine, and this is D is the distance of normal from the origin. So direction cosine is this, and distance of normal from the origin is 5 by root under 14. Question number D, 5y. First of all, when we will write this, we will write -8. Always remember one thing, D will never be negative. So first we have to make this as positive. So we can write -5y equal to 8. Now x and y coefficient is, x and z coefficient is 0. So 0x minus 5y plus 0z equal to 8. So this is very important step. So 0 minus 5 and 0. This is nothing but the direction ratio and square value of this, and after that take the root and divide it by 5. So minus 5 equal to 8 by 5. So 0, minus 1 and 0, this is nothing but the direction cosine of the given in the given plane, and 8 by 5 unit is the normal from the origin, distance of normal from the origin. Question number 2, find the vector equation of the plane which is at a distance of 7 unit from the origin and normal to the vector 3i plus 5j minus 6k. So normal vector, we can not, this is normal to the vector, this is given. So unit vector n, we can find out n vector divided by mod n. So 3i plus 5j minus 6k divided by 3 square, 5 square, 6 square, and this is the value. Now, it is known that the equation of the plane with position vector r is given by r dot n equal to d. R dot n equal to d. So we know the value of n unit vector. So r dot unit vector n equal to 7. So this is the vector equation of the required plane. Question number 3. Find the Cartesian equation of the following plane. It is given in the r dot n equal to d format, and we have to convert it into the Cartesian form of equation in the Cartesian form. So r dot I plus j minus k equal to 2. So for any arbitrary point p x y z on the plane, position vector r, this is nothing but the value of r equal to xi plus yj minus zk. Now we have to substitute the value of r in the equation first. R xi plus yj. Now, for any arbitrary point p x y z on the plane, we can take xi plus yj plus zk. This is the plus, this is plus zk. Now this value we have to substitute in place of r, and we will take the dot product. We'll take the dot product. So xi plus yj plus zk here. This is again printing mistake, zk. So I dot I 1. So this is x, y, and here this is both are positive. First we will see. Now here x, this is y, and this is 1 y, and this is plus, this is minus. That's why this is minus here, and z into 1. That z. This is the Cartesian equation of the plane. So always you have to remember r dot n equal to d. This value is given. So with this value we can take as xi plus yj plus zk, and after that just we have to dot product of these two vector. We will find out, and this will give the Cartesian equation of the plane. R dot this value. So arbitrary value xi plus yj plus zk, here also plus zk, and this value we have to substitute in place of r. So after substituting the value, we are getting here. So this is x into 2, this is 2x, y, 3y, and this is plus, this is minus. So minus 4z equal to 1. C, r, this is the value dot n equal to d. So for any vector xi plus yj plus zk, we can take, substitute the value of this in place of r, and getting the value, just multiplying this value. Now this is x, and this is s minus t. So s minus 2tx plus y into 3 minus ty, and z into 2s plus t equal to 15. This is the Cartesian equation of the plane. Question number 4. In the following cases, find the coordinate of foot of perpendicular drawn from the origin. This is the plane. This is the given plane. Suppose we draw A from the origin and this is the foot of perpendicular, then this value we have to find out. So for this we have to, and we know this foot of perpendicular we can find out just by L, M and ND. This is the value of foot of perpendicular. So first step, we have to find out the value of L, M and N. So this is the given plane. This is the plane is given. So first of all, we have to find out the direction ratio. So let the foot of perpendicular from the origin be x1, y1, z1 we are taking. This is the equation of the plane. This constant we have to take the right side. So this is the equation of the plane and this is positive. It should and must be positive because ax by cz plus d equal to 0. This is in this form. But always remember when ax plus by plus cz equal to d, when we are taking equal to d. So this should be positive. Now 2, 3, 4 is the direction ratio. Take the square root of that value, that is 2 square, 3 square, 4 square. After that, in the equation of the plane, we have to divide this value. After dividing, it is in the form of Lx my nz equal to d, where Lmn is nothing but the direction cosine of normal to the plane and d is the distance of normal from the origin. So 2 by root under 29 is the L value, 3 by root under 29 is the M value, 4 by root under 29 is the N value, and 12 by root under 29 is the D value. So coordinate of foot of perpendicular are given by, always remember this value, L, M and D, just multiply. So after multiplying, we are getting this value. Okay, that is 24 by 29, 36 by 49 and 48 by 29. This is the coordinate of foot of perpendicular. For the second equation, 3y plus 4z minus 6. So x value is 0 here. So 0x plus 3y plus 4z equal to 6. So direction ratio of normal is 0, 3 and 4. So just we take the square value, this is coming 5. Just divide this 5 to the plane and we are getting 0x 3y by 5 plus 4z by 5 equal to 6 by 5. So this is the Lx plus my plus nz equal to d. L, M, N are direction cosine of the normal to the plane and d is the direction, d is the distance of normal from the origin. So same, we have to multiply this two value L, M and LD, MD and ND, and this is the coordinate of foot of perpendicular. Just after multiplying, we are getting this is the value. Similarly, third question, x plus y plus z, direction ratio is 1, 1, 1. Just divide it by root 3. We are getting this value, and foot of perpendicular is 1 by 3, 1 by 3 and 1 by 3. Coordinate of foot of perpendicular 5y plus 8 equal to 0. So when we are writing, this is very important. So when we are writing 5y equal to minus 8, first we have to make this positive. So minus 5y equal to 8. After that, we have to write 0x minus 5y plus 0z equal to 8. And after that, just we have to divide by root under 5 square, that is 5. After dividing, minus y equal to 8 by 5, Lx, My and z. So L, D, MD and ND we can find out here. So 0, minus 1, 8 by 5. This is the value is minus 8 by 0, minus 8 by 5 and 0. This is the foot of perpendicular. Find the vector equation and Cartesian equation of the plane. Now it is given that passes through the point 1, 0, minus 2 and normal to the plane. This is normal to the plane. Second question, it is passing through the point 1, 4, 6 and normal to the plane I minus 2j plus k. Now, first of all, The position vector of the given point we can write 1 0 minus 2, we can write a equal to I minus 2k. I minus 2k based on this I minus 2k. Now normal vector n perpendicular to the given plane, we can write n equal to I plus j minus k. This is the given value here, normal to the plane, I plus j minus k. Now vector equation of the plane is nothing but r minus a dot n equal to 0. After that we have to substitute the value r minus a value is I minus 2k and n is I plus j minus k equal to 0. Now r is the position vector of any point p x y z, and r we can take xi plus yj plus zk, and this we have to substitute in the given equation first. Then we are getting xi plus yj plus zk, and just we have to multiply and solve this. After that, this is the Cartesian equation of the plane we got. Now B, the point is given 1 4 6. So for 1 4 6 we can write the position vector of A, we can write here I plus 4j plus 6k. Now normal vector n perpendicular to the plane is given n equal to I minus 2j plus k. So vector equation of the plane we can write r minus a dot n equal to 0. So this is the vector equation of the plane. We have to substitute the value of a and n. Later we can take to convert the Cartesian plane xi plus yj plus zk. So for the vector equation, this is nothing but the r minus a dot n. This is the vector equation. So r is the position vector of any point, then x, y, z in the plane. So r equal to xi plus yj plus zk. And we have to substitute the value and just do the calculation here. First of all, this value and this value, after doing the calculation, this is x minus 1i, y minus 4j, z minus 6k, and I minus 2j plus k. So this is x minus 1, 2, and this is the product of this value and this value. So I dot I1 and plus minus minus 2, y minus 4, z minus 6. So this is the Cartesian equation of the required plane. Question number 6. Find the equation of the plane passing through 3 points. So in this type of question, what we have to do? First of all, we have to find out the determinant value. So the given point, suppose A, B, C we can take, and first of all we have to find out the determinant value. 1 1 minus 1 we have to write in the first row, 6 4 minus 5 and minus 4 2 3. After finding out the determinant value, it is getting 0. The meaning of 0, it indicates that A, B, C are collinear point. So there will be infinite number of plane passing through the given point. This is the first step. That means first we have to find out the determinant. If it is equal to 0, that means there are infinite number of plane passing through the given points. Second point is A, B, C we have to take, and this value of determinant is not coming 0. So this is not coming 0. The meaning is there is a plane passing through ABC. There is a unique plane which is passing through ABC. And equation of the plane in the Cartesian form, we know that if x1, y1, z1, x2, y2, z2, and x3, y3, z3. If this is the 3 points are there, then equation of the plane we can write here x minus x1, y minus y1, and z minus z1. And this is the direction ratio we have to find out. x2 minus x1, y2 minus y1, and z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1. So x minus, this is the point, just we have to substitute 1 1 and this is 0. After that, x2 minus x1, this all the value just we have to find out and substitute in this determinant value. After getting, we are getting the equation 2x plus 3y minus 3z equal to 5. and this is the required equation in the Cartesian form. Question number 7. Find the intercept cut off by the plane. So wherever the word cut off, intercept, this type, so equation of the plane we know x by a plus y by b plus z by c equal to 1. This is the required equation of the plane. So in the question number 7, intercept form always x by a plus y by b plus z by c. In this format, first of all, we have to bring. So for that, in the right hand side, if you will see, this is the constant 5 is there. So divide by 5 in the left and right side. So we will get this value. This is the value. Now making the coefficient unity. So for that we have to write like this: 5 by 2, y by 5, z by minus 5. And we know the equation of the plane in the intercept form is x by a plus y by b plus z by c equal to 1. So where a, b, c are intercept cut off by the plane x, y, z. So intercept cut off by the plane, a value is 5 by 2, b value is 5, and c value is minus 5. Find the equation of the plane with intercept 3 on the y-axis and parallel to ZOX plane. So ZOX plane parallel. So if we draw a 3D, this is x, y, and z. So this is ZOX plane. So equation of plane ZOX, what we can write? Y equal to 0. So any plane parallel to it, we can write y equal to a. Now it is given the plane intercept 3 on the y-axis. So a value is 3. So the y-intercept of the plane is 3. So the equation of the required plane is y equal to 3. Question number 9. Find the equation of the plane through the intersection of the plane. There are two planes. One plane is 3x minus y plus 2z minus 4 equal to 0, and x plus y plus z minus 2 equal to 0. So suppose this is the P1 and this is the P2. So we know the equation of the plane when it is passing through the two plane. We can write P1 plus lambda P2 equal to 0. So once we will substitute this point in the given plane, P1 plus lambda P2, we will get the value of lambda, and after that just we have to substitute the value in the given plane. So equation of any plane through the intersection of the plane, we can write here 3x plus minus y plus 2z plus alpha x plus y plus z. So this value and this value. So in the alpha we take. Now this is the required equation of the plane, and which is passing through the point 2, 2, 1. So we have to substitute the value 2, 2, 1 in this plane. So after substituting the value, we are getting 2 plus 3 alpha equal to 0, alpha equal to minus 2 by 3. So just we have to substitute in the equation first, and after doing the calculation, this is alpha value minus 2 by 3. Just we have to do the calculation, and we got the answer 7x minus 5y plus 4z minus 8 equal to 0, which is the required equation of the plane. Question number 10. Find the vector equation of the plane passing through the intersection of the plane. So two plane is given in the vector form. In the last question, it is given in the Cartesian form. So there also the same concept. Suppose one plane P1 plus lambda P2 equal to 0. So both in the Cartesian or in the vector form, we will apply the same equation. So equation of the plane R1, this is given, and R2, this is given. This is the two plane is given, P1 and P2. This is nothing but the plane equation. So equation of any plane passing through the intersection of first and second, we can write here. First of all, we have to bring this in the equation format. So r dot 2i plus 2j minus 3k minus 7 plus lambda. This is the equation. So where lambda belongs to r. Now after that, we have to write r dot 2i plus 2j minus 3k, and here same we can write because r is common. So 2i plus 5j plus 3k. Now this value minus 7 and minus 9 lambda. Once we will take in the right hand side, so this value is here. So r dot 2 plus 2 lambda I, 2 plus 5 lambda j, 3 lambda minus 3k, 3k. This is 9 lambda plus 7. Now this plane is passing through the point 2, 1, 3. So its position vector, first of all, we have to write its position vector. So r equal to 2i plus j plus 3k, and this value we have to substitute here and find the value of lambda just by dot multiplication. So once we write the dot value here, and this is the value, that is 9 lambda plus 7. So I and I is here, so 2 plus 2 lambda, j and 2 plus, and here k 3 lambda minus 3. Now after that lambda value we got, and just we have to substitute in the given equation. So r dot 38 by 9 I plus 68 by 9 j plus 3 by 9 k. So this is the vector equation of the plane. Question number 11. Find the equation of the plane through the line of intersection of the plane x plus y plus z equal to 1 and 2x plus 3y plus 4z equal to 5, which is perpendicular to the plane. Now, in this type of question, what we have to do? We know the equation of the two plane. So first plane, always remember p1 plus lambda p2 equal to 0. This is the equation of the required plane. So x plus y plus z minus 1 plus lambda. So whatever the constant in the right hand side, that you have to bring in the left side. So 2x plus 3y plus 4z minus 5. After that, x value we can write, this is x, this is x. So 1 plus 2 lambda x. Similarly, 1 plus 3 lambda y. After that, 4 lambda plus 1 z minus 5 lambda plus 1. This is equal to 0. Now, when we converted this into the form of ax plus by plus cz plus d equal to 0, so this is the required equation of the plane, and whose direction ratio is x coefficient, y coefficient, and z coefficient. This is nothing but the direction ratio of the given plane. This is the direction ratio. Now the plane is perpendicular to this plane, so direction ratio of this plane is 1 minus 1 and 1, and we know direction ratio of this two plane. Since the plane are perpendicular, so this is the condition when two planes are perpendicular, a1 a2 b1 b2 c1 c2 equal to 0. So 2 lambda plus 1 minus 3 lambda plus 1, 4 lambda plus 1. Lambda value is minus 1 by 3, and this value we have to substitute in the required equation, that is in the equation first, and we get this is the required equation of the plane. Question number 12. Find the angle between the planes whose vector equation are. This is the vector equation. So always we know to find out the angle cos theta a dot b. Cos theta equal to a dot b divided by mod a mod b. So first of all, equation of the plane are, this is the second equation. Now it is known that if n1 and n2 are normal to the plane, so r dot n1 and r dot n2, this is the equation of the plane. Now angle between them we can write cos theta equal to n1 dot n2 divided by mod n1 dot mod n2. So this is the equation of the plane, angle between the two planes. Now n1 we can write here 2i plus 2j minus 3k. This is r dot n. This is r, this is n1, this is n2. So this is n1 and this is n2, and after that we have to apply in the formula directly. n1 n2, n1 dot n2 first we have to find out, and mod n1 n2 we have to find out the value and substitute the value. Now this is cos theta equal to minus 15 root under 17 root under 43, and mod value is positive, so this is the required angle between two planes. Question number 13. In the following cases, determine whether the given plane are parallel, perpendicular. In case they are neither. Find the angle between them. So one by one we will see all the questions. First of all, clear the theory. So suppose L1 equal to, so direction ratio of normal to the plane A1x B1y plus C1z equal to 0. This is the direction ratio. And in this case, A2 B2, this is A2 B2 and C2. A2 B2 and C2 is the direction ratio of normal to the plane. If they are parallel, then the relationship between the direction ratio is A1 by A2, B1 by B2 and C1 by C2. And if it is perpendicular, then A1 A2 B1 B2 plus C1 C2 equal to 0. An angle between two plane is cos inverse A1 A2 B1 B2 C1 C2 by A1 square B1 square C1 square, A2 square B2 square C2 square their root. Now, equation of the plane are, this is the equation of the plane where A1, B1 and C1 and A2, B2 and C2 value. So first of all, our task is to find out A1, A2, B1, B2 and C1, C2. This is not equal to 0. So therefore the given plane are not perpendicular. So the given plane are not perpendicular. And we have to take the ratio A1 by A2 7 by 3, B1 by B2 5 by minus 1, that is minus 5, C1 by C2 is minus 3 by 5. So this all are not equal. So this all are not equal. So this is not a parallel. So they are neither parallel nor perpendicular. So in that case, we can find out the angle. So A1, A2, B1, B2, C1, C2 divided by whatever the value of root A square, B square, C square. This value just we have to substitute, and this is the angle. In this way, only all the four questions we have to do. Now, in this way, in this question B, A1, A2, A1, B1, C1, A2, B2, C2. So A1, B1, C1 is nothing but 2, 1 and 3. And in this 1 minus 2 and C2 is equal to 0. So A1, A2, A1, A2, B1, B2, C1, C2, we have to find out this value is coming 0. So if it is 0, then definitely planes are perpendicular to each other. C, 2x minus 2y plus 4z plus 5. So first of all, A1, A2, B1, B2, C1, C2 we have to find out. This is not equal to 0. So definitely it is not perpendicular. Similarly, this we have to find out ratio, and this is nothing but all are equal. A1, A2, B1 by B2 equal to C1 by C2. So definitely this is parallel. D, the equation of the plane are, this is the equation of the plane. A1 by A2, B1 by B2, C1 by C2 all are equal. Definitely this is parallel. And E, first of all, direction ratio we have to find out. And they A1, A2, B1, B2, this is not coming equal to 0. So this is not perpendicular. So A1 by A2, B1 by B2, this is also not equal. So definitely this is not parallel. So in that case, we can find out the angle. So that is cos inverse A1, A2, B1, B2, C1, C2 divided by root of that value. This is 45 degree. Now, in the following cases, find the distance of each of the given point from the corresponding given plane. Now, when the point is given and the plane is given, so ax plus by plus cz plus d equal to d, and the point is given, and we know the distance is nothing but a1 ax1 plus by1 plus, just we have to substitute in place of xyz and divided by this value. That means this is the point and this is the plane. This is same as equation of straight line we know. Same this is in the plane. So 0 comma 0 comma 0, and suppose this is 3x minus 4y plus 12z minus 3. So we have to find out the d. So what we have to do? We have to substitute in place of x, y and z. After that, taking the mod divided by root under 3 square plus minus 4 square plus 12 square. So whatever the answer we will get the value. So just we have to substitute 0, 0. This is, and distance is always positive. So this is 3 by 13. Similarly, 3 minus 2, 1. This we got 13 by 3. All questions are say repeated type. So this is 9 by 3. Just we have to do the calculation. and this is d is equal to 2. So I hope this is crystal clear for all of you, and this exercise is very, very important. You have to do the practice. Thank you.